Managing graphs and sessions. So managing graphs and session is a crucial aspect of working with TensorFlow. Understanding how to create, manipulate, and execute graphs and sessions allows you to build and train complex machine learning models effectively. Let's delve into the details of managing graphs and sessions in TensorFlow. So TensorFlow graphs. A TensorFlow graph or a computational graph is a data structure that represents a series of TensorFlow operations, which are the nodes, and the flow of data tensors between them. Now the default graph, TensorFlow automatically creates a default graph when you define operations. Operations are added to this graph by default. Multiple graphs. You can create multiple graphs in TensorFlow and execute operations within specific graphs. Now, how do you create and manage graphs? So here is an example. So import TensorFlow HTF. Say graph equal to tf.graph. This is how you create a new TensorFlow graph. And now to add operations, you say graph.asDefault. Add the operations inside there. A equal to tf.constant, b is equal to tf.constant, and c to tf.add a and b. So this will add that and add it into that graph. TensorFlow sessions. Definition of TensorFlow sessions is TensorFlow session provides an execution environment for TensorFlow operations within a specific graph. It encapsulates the computation and allows you to run operations and compute the output of tensors. Session options. TensorFlow sessions support various options such as specifying the device to execute operations on, configuring thread pools, enabling GPU memory growth, etc. That's how do you do this? In this example, you see I'm creating a TensorFlow session with tf.compat v1 session, graph equal to graph ss. Execute operations within the session by saying result equal to session.run and display the result out by using the print statement. Now default graph and sessions. TensorFlow operations are added to the default graph by default unless explicitly specified otherwise. Now default session is TensorFlow allows you to designate a default session for running operations without explicitly passing the session object. Here is an example of a default session where with dtf.compat v1 session is sesh, which creates a TensorFlow session. You execute operations without specifying the session by saying result equal to session.runc and print it out. Closing sessions and resource management. Now closing sessions, TensorFlow sessions should be closed explicitly to release resources, especially when working in TensorFlow 1.x. Resource management. TensorFlow provides mechanisms for managing resources such as using context managers with statement is the one to ensure resources are released properly. Example of closing one is sesh.close. So you can just close the session. Configuring sessions. You need session config. TensorFlow sessions support various configuration options such as specifying the log device placement, setting the number of threads, configuring the GPU options, etc. You can also use tf.compat.v1.config proto. Use this class to configure session options. Example is here, where it's a config equal to tf.compat.v1.config proto. This will create a configuration. It's a config.log device placement equal to true, config.gpu options allow growth equal to true, so you can create the configuration. And using the creating a session tf.compat v1 session, you can just run the session in there using the sesh.run and print the result. Managing graphs and sessions in TensorFlow is essential for building and training machine learning models effectively. By understanding how to create, manipulate, and execute graphs and sessions, you gain insight into the structure and behavior of your models, enabling efficient development and debugging. TensorFlow provides flexibility and scalability for managing graphs and sessions, allowing you to customize execution environments and optimize resource usage for different scenarios.